So you've looked at the gravitational potential energy stores of objects, and you've looked at the kinetic energy stores of objects. In this video, we're going to focus on the thermal energy stores of objects. Now, materials have got a property called the specific heat capacity. Okay, and this is specific to those materials. Now, the specific heat capacity of a material is the amount of energy you need to put into that material to raise 1 kilogram of it by 1 degree C. Okay. Okay, and the key words here, so 1 kilogram of an object by 1 degree C. If you are asked to answer a question in an exam, what defines specific heat capacity, something like that, then you need to mention the fact that it's 1 kilogram of an object and the temperature is being raised by 1 degree C. It's the amount of energy needed to do that. Okay, so there is an equation that involves specific heat capacity and thermal energy. Now, if you wanted to heat an object up, you need to give it some thermal energy. You need to transfer some energy to it. Now, the amount of energy that you transfer to the material, okay, we're going to represent that as delta E. So delta just means change in. Yeah, so it's a change in energy. The amount of energy you transfer to the object is going to equal the mass of the object multiplied by its specific heat capacity, which we're going to represent with the letter C, times by the change in temperature. Okay, and temperature I'm representing with the Greek letter theta here. Okay, now thankfully you are given this equation in your formula sheet if you are doing an AQA exam, so you don't need to remember it, but you do need to know how to use it. Okay, now delta E is our change in thermal energy store, represented given the unit joules. Okay, M is our mass in kilograms, of course. C is our specific heat capacity, and delta theta is our temperature change, or our change in temperature. Okay, given the unit degree C. Okay, now you can do a little bit of unit analysis on this if you want. You can figure out the unit of specific heat capacity. It is joules per kilogram per degree C. Okay, there's your unit of specific heat capacity. So let's use this this pan of boiling water as an example. Now let's say we wanted to bring this pan of water to the boil. Now maybe the initial temperature is 25 degrees. Okay, so 25 degrees C. Maybe there's let's say there's 1.5 kilograms of water in there. Okay, so 1.5 kilograms of water in the pan, and we want to bring it to the boil. Okay, firstly you need to know the specific heat capacity of water. This is something that you will likely be given if you're not asked to work it out. The specific heat capacity of water is 4,200 joules per kilogram per degree C. Okay, now if we wanted to work out the amount of energy we need to transfer to raise its temperature from 25 degrees to boiling point of water is 100 degrees. So what do we do in this case? Well, we have to take the mass, which is 1.5, times it by the specific heat capacity of water, 4,200, and multiply it by the temperature change. So if we're taking it from 25 up to 100, then the temperature change is 75 degrees. Okay, so multiplying all of those numbers together, you get 472,500 joules, okay, or 473 kilojoules. So a huge amount of energy, really. Okay, water does have an unusually high specific heat capacity compared to most materials, so it does take a lot of energy to warm it up. But we can figure out how much energy by using that equation, that specific heat capacity equation. Change in thermal energy is equal to the mass of the material times by the specific heat capacity times by the temperature change. Now, it's specific heat capacity, it's specific to that material. Okay, so every single material has a different specific heat capacity. Okay, water has got a particularly high one. Something like, say, mercury, I think is something like 140, 150, something like that. Okay, so it's much smaller, much lower. Right, that's specific heat capacity. I do have a video actually on the required practical to go along with this. So I will just link that in the end of the video anyway, and you can watch that if you need to. I will see you in the next video.